we go. We're going to talk about solving quadratic inequalities. I'm trying to block this so you can't write it down, because you don't need to write this down yet. So, did everybody get a piece of paper? A piece of the thing? Okay, so a quadratic inequality is exactly like a quadratic function, only it has an inequality instead of an equal sign. Okay? So normally you find f of x. Y is the same thing as f of x. Okay? So it can be y is less than ax squared plus bx plus c, less than or equal to, greater than or equal to, yada yada yada. So it can be written as in those 4 ways. Y can be a number, it can be y. Zoom in. Is that better? Yeah. Okay. So the solution is not just a number, it's an ordered pair. So there's 2 numbers, there's an x and a y. Because normally from what you guys have been doing so far, you've been doing zeros and find the solution, find what x equals, but this time it's a solution that has an ordered pair, which is like a point on the graph, right? A location on the graph. So okay. So the next part is, if we want to graph, so the most interesting thing about quadratic inequalities is what they look like on a graph. So when we graph them, there's certain things we have to do. So the first thing we're going to do is we're going to graph the parabola that defines the boundary. So when we talk about boundaries, we're talking about less than or equal to, stuff like that. There's going to be some sort of boundary, like here, we have a parabola that will define, well, is the stuff inside it, is it outside it, what's going on here. So our first thing to do is we're going to solve the parabola, we're going to graph it, and really the 3 things you need to graph a parabola are the vertex and the roots, and that's really all you need. Or a vertex and 2 points if it doesn't actually have any roots like this one. I think graphing the parabolas are probably the easiest thing to do. The easiest. Can you see past this? Okay. All right. So we're going to draw these pictures. So if you have a less than or equal to or greater than or equal to situation, you're going to draw a solid parabola. If you have a less than or greater than situation, you're going to draw a dashed parabola. Do you know why we draw it that way? Can you tell me why? You can nod in your head, Zach.
Because it's equal than to or less than.
Right, so
it's including it.
Including, right. So if I have less than or equal to, it's including it. It could lie along the parabola, right? If it's strictly greater than or strictly less than, we like to say it doesn't actually lie on the parabola. It's like around it, not exactly on it, right? Do you guys remember graphing lines and having less than or equal to, stuff like that? So it's kind of the same thing, only now we're dealing with parabolas. So instead of a straight line, you're dealing with a curve. All right. And then...
What O is that? Oh, it's an and sign?
And, yeah. Am I going too fast?
Yeah.
I'm sorry. I'm sorry. Tell me if I'm going too fast. Sorry. I'm just so excited about quadratic inequality.
Put away that negative attitude.
Who's being negative?
No one, I'm not a snitch.
Get out.
Classroom rule number 2, tell the truth.
Tell the truth. Be nice.
I am cat.
It was
Would
her.
you lie to us?
Positive poly.
Is that a thing?
Sure, it is now.
It is now.
Oh, great.
I hate this already.
Negative Nelly.
There's also Debbie Downer from SNL.
Positive.
Wah, wah. Okay. So just in case, if you're done writing this down, the next part. So, if I have.
I totally just mixed your dentist to graph quadratic inequalities.
Donald Downer?
There
You're Danny.
Really?
Donald Downer.
Okay. Debbie Downer, Donald Downer, what have you, whatever. Okay. Don't even. Oh my gosh, I swear. Okay. Shade above the parabola for y is greater than or equal to, and shade below it for y is less than or equal to. Pretty straightforward, I like to think. Do you guys want to know how I made my dashed parabola?
You dashed when you drew.
Nope.
Pretty much you drew it and then erased it.
Yep, that's what I did. I did this number. I did it like this. It's easier to do with whiteboards.
That just looks like a spiky parabola.
Not anymore. That's what I did.
It's a lot more fun with the chalkboards because just like I forget what you do, but it's just like you can draw a dashed line without even moving your hand really. Like if you draw it fast enough.
Okay. Oh, I will punch all of you in the face if you.
Punch him in the throat.
Bo and Kobe, did you guys match on purpose today?
Or when you take like new pictures.
His face is so great. He's like, oh, he just now noticed. Oh, I love it. That's so great.
Or when you take like perfect like picture paper and you like last year, you know like photocopy papers?
Uh-huh.
They're like kind of squeaky.
Oh, no.
Do you remember essays from last year with chalkboard?
Yeah.
I always hated it when you used it.
I can't use a chalkboard. I'm a whiteboard person. I love the whiteboard. Although I get dirty every time I use it.
That needs to be done now.
What are you
Then you can see
doing?
you're trying to.
Oh.
I hate the way it sounds when chalk is writing.
Yeah, it's gross. I don't like it either. Okay. I'm going to move this up a little bit, if I can. Okay, so I want you to write this. Hopefully you have some room left below your paper. Lots of room. You should have at least, like I have like half a page, basically.
Half a page.
That's not.
Well, just kidding. That's not half a page. JK.
A fourth?
Just kidding. Can you guys see this okay?
Lying to us.
I'm sorry. I don't know, I just broke my own rule.
Come on. Good program.
Wait,
Today is a weird day for me, you guys.
Wait, what?
Number 2.
Are you feeling better?
I am. I still have a tiny bit of congestion, which is a bummer, but
You're sounding more like yourself.
thank you. Is that good? I know you told me you like it when I'm sick, so.
You want to share a drink?
No. Are you sick?
Yeah.
Oh. No, thank you. Ew.
Sure. You're doing what they do. She's really sick.
Okay, let's see if I can find the book on this one. Because I wrote this down. And then I immediately forgot what to do. Do you guys ever do that?
Yeah.
You like write something down and you're like, I'm gonna do that, and then you can immediately forget.
Pinterest. Yeah.
If you go on Pinterest and you're like, I went here to find something, and I forgot what I was gonna find.
You totally know. I have like 5 boards full of things, to-do lists, and like DIY crafts and stuff, and I'm like, ooh, I'm gonna
Okay, here we go.
this and this and that.
I don't know how to use Pinterest. I get on and I text up.
Okay.
And then
I just remembered now what I'm gonna do. Okay, we need to find the vertex. So what form is this in, first of all? Standard. So to find the vertex in standard form, I was gonna make you a cheat sheet. Maybe we'll do that later. What do I use to find the vertex in standard form? Negative b over 2a. Okay, over 2a.
That's how you find the vertex.
That's how you find the vertex. And the axis of symmetry. And the maximum minimum. They're all the same. Okay? So this is going to give me positive 4 over 2 times negative 2. So 4 over negative 4 is what? Negative 1. So now I take that to find the y coordinate. I do what?
Plug it in.
I plug it back in. So negative 1. Okay. So this is going to be... No, I'm sorry.
Boy, watch your language.
So negative 2 plus 4 plus 6 is 8.
I find it really funny when people
Huh?
don't even say bad words and people are like, watch your language. It's like,
Don't say it.
So vertex is negative 1, 8. Does this one open up or down?
down.
Down. Okay. And the roots, I think we could factor this.
Oh, so for primary roots, we just do
Take 2x out.
Yeah, you can, so finding the roots, you can do whatever you want, basically.
Take 2x out of it.
I can take 2 out of it, first of all. If I divide everything by 2, I'm going to divide everything by negative 2, actually.
That's what I asked.
Negative 1, 8. It's not to scale, but I don't care. It's not that bad. And then, so roots, I'm going to do, this is negative 2. No, I keep breaking my pencil. I can't stop writing so hard. So x squared, negative 4 divided by negative 2, that's plus 2x minus 3. What multiplies to negative 3 and adds to positive 2?
1 and 3.
1 and 3? Negative 1 and positive 3. So my roots are right here at x equals 1, x equals negative 3.
Wait, what about the 2?
I can just, since you're setting it equal to 0, 0 divided by negative 2 is just 0, right? Right.
Even though it's not to scale.
So here's, I know it's not to scale. Maybe I'll move this one.
Oh shoot. I don't have enough room.
We're just estimating at this point. Whee! Your graph doesn't have to be perfect.
Well, the vertex is not a root.
Yeah. These are your roots, right? 1 and 0, negative 3, 0. Okay. So now we have the parabola graphed, hopefully. It may not be perfect, but that's okay. How'd I get what?
Yeah.
Do you guys follow me so far? Up until this point? Hopefully? Okay. So it says y is less than that. So where should I, yes sir.
You didn't dash the parabola.
I didn't dash the parabola. Parabola.
Parabola.
Do we have question?
Huh?
With the roots part, 0 equals negative 2. Do you just leave the negative 2 alone and it disappears?
Yeah, because I can divide by negative 2, right? It's dashed because, yeah. If it's not including, if it's not or equal to, you have to dash the parabola. But you just take your eraser and just dash it.
I like pens.
And then isn't it outside the...
So y is less than, so it has to be, well, it's below, right? So it'd be down here.
Don't you kind of hate lessons?
Right? It opens down. Like this one opens up and it's below, but this one opens down and it's below, right? Okay. You guys follow me so far? Why is it what? In? Oh, it's just, so this one opens up, so it's below it this way, but this one opens down and it's below it on the inside.
Wait, so why is it below?
Because it's y is less than.
So if the other one opened down, then it would be up.
Exactly. Yeah. So this is not just an equation. It's an inequality. Y is less than these values here. Does Does that
Oh,
make
so
sense?
that's like.
That's why it's shaded and that's why it's below it, yeah.
Why do they call it below it instead of just inside and outside?
Because this one, it's not inside and it's still less than, but it's below all those values. And it's kind of hard to visualize when you first start talking about it, but this, I mean, up until this point, do you guys follow me? Kind of? Okay. What I would like for you to do...
Wait, hold on.
Okay, sorry. I had to like look at the graph to make sure I did it right. Okay. So that only took 25 minutes. What the heck?
It's not a good
I need to slow down.
Well, now we have
Sorry.
time to do the homework. Yeah,
Free time? I don't think so.
More time to do the homework.
More time to
Then
do
free
homework.
time to
Yeah.
sleep.
Well,
Free time.
okay. Let me look at this guy. Okay. But I want you to. Oh, my plans. This is my plan for today. Like it's just right here. Anyway, okay. What I want you to do now is take this guy. Tape this in on the left-hand side like a book. I have tape here. There's tape there. There's also glue if you want glue. Are you guys good here? Can I take this down? Right? Yeah? Okay.
What side do you want us to
This side. So, just like,
And like a book.
in like a book.
So that it can fold out.
Yeah, so like, whee!
Top one. Bad.
Okay.
Disappointment.
What the inequality? That's what it says. What the heck?
What the
Oh, wait, so you want it to where it's clear answer?
Yes, because it's two-sided.
It's alright. Oh.
It says the guy can get up. And Dylan, I want these.
You can wait to tape it in too. I mean, that's fine.
Eating the baguettes.
Okay. I'm gonna put my name. Here's my name. Not that it matters.
I was gonna say Miss.
Why are we putting our name if it's in our book? Nope.
You don't have to write your name. I just feel like writing my name.
I wrote my name.
Good for you.
It's like a salt shaker.
Period for
What's
Good for you.
inside of your tape, ma'am?
sand, I think. To keep it from, yeah, to weigh it down.
This one would be.
This is my favorite school supply that I bought.
Like,
Why?
It's so
My adorable stapler. It says poppin' on the outside of it. Anyway, that was like 12 bucks, by the way.
why?
Because it's a certain brand thing. That was free.
$3.99.
Free. For my master teacher when I was student teaching. She's like, everybody needs a tape dispenser.
$3.99.
She sounds like that exactly.
Yep.
Oh.
Yep. Okay. Translate the following statements into words and provide two values which satisfy the inequalities. This is going to kind of reintroduce us to inequalities. So, how would I read this guy?
S is greater than 4.
S is greater than 4. And that's what we're doing in my algebra classes, actually. We're just talking about inequalities. So we just started out absolute value inequalities today. So give me two values that are bigger than 4.
7 and 9.
7, 9, 18, infinity, whatever.
4 trillion and 12.
4 trillion and 12. Whatever. How about B?
5 is less than or equal to that.
Okay. 5 is less than or equal to x. Or, how else can I say it? What's another way I could say it?
X is greater than or equal to 5.
Yep. Either way. I'm going to do x is greater than... I like the variable on the left. Or equal to 5. Okay? I'm going to say 5. Does 5 work?
Yeah.
Okay? And then what else?
8.
10, 8, whatever.
11.
11. Be confident. That was a good answer. All right. How would I say this one? Z plus, oh, I was just gonna rewrite it. Less than 4. So what's one value that would work? 0.5. What value would not work? 1, 2, 3.14159263. 5.
Would negative numbers?
Negative numbers could work, yeah. So negative like 2, negative 5, negative 1, whatever.
Is this what our homework will be like?
I wish.
Negative 72,356.
Okay, so let's talk about this. Sketch the inequality from above on the number line below to show all possible solutions for the inequality. So z is greater than 4. Well, here's 4. Do you remember what kind of circle I'm going to put on 4? I represent them with open or closed circles. Open because 4 is not included, right? And then I'm going to go which way, left or right?
Right.
Right, because it's getting bigger, right?
That's the arrow.
The arrow's pointing right.
This is so cute.
I know. This is what we're doing in algebra. Yeah, draw a squiggly line. Yeah. How about this one? So that it represents, it's all of these numbers going this way. On forever.
Closed circle.
Closed circle where?
Over there.
Over there at 5, right?
Sure.
And then going to the left or the right? Well, which one? Wait.
Right.
To the right.
Is greater.
X is bigger than or equal to 5. So I'm getting bigger, so I'm going to go to the right.
Oh yeah.
Yeah. That's why whenever we graph these, we usually like the variable on the left. Makes it easier.
We should do it with Jackson.
I know, right? Be like, Jackson, we did the same thing today. It was awesome. How about this one? Where am I going to have my... Okay, so what number am I going to put here as my defining number? Z is less than what? 1, because I subtract 3, right? Open circle or closed circle?
Open.
Open, going which way? Left. Hooray. My graphing skills are not that great, but that's okay. All right. Woohoo. Okay. How do the ideas of inequalities such as above apply to graphing quadratics? Well, let's explore it. So here's a graph. Where's my vertex at this guy?
2,
1.
2, 1, 2, 1. Okay, so here's 2, 1. Not that it matters, I was just curious. Okay, when x equals 3, what is f of x? What does f of x mean, first of all? If I have 3,
What is the function?
what is the function value at x equals 3? Well, I can do a couple things. I can plug in 3 for x, and I would get 3 minus 2 is 1 squared plus 1 is 2. Or I can say, oh, well, here's 3. It's right there. It's 2. So when I plug in 3 for x, or when I go over here and I find 3, I get 2. Okay, so when the function value is 5, so when basically you can think of this as when y equals 5, so let's find y equals 5, here's 1, 2, 3, 4, 5. What is a possible value for x?
Oh.
4.
1, 2, 3.
1, 2, 3, 4, 5. So there's 1 here and there's 1 here. So what is a possible value? 1? Ah, 1's over here. 0?
0 and about 4.
About 4-ish?
So about 0 and about 4.
Yeah? Is there more than one possible value?
Yes.
I see 2. There's more than one possible value, right? Yeah, because 1, 2, 3, 4, 5. Here's my y value at 5. If I look across here, I have, oh, there's 1 there and there's 1 there. So yes, there is more than one value for x. All right. So what would I need to change about this graph to show that the function, so here's my function right here, here's my parabola. I want all the values that are less than or equal to this function. What would I have to do? Sorry. Yes, ma'am.
Why is it
4-ish? It looks like 1, 2, 3, 4-ish. It's not exactly on 4. Right, what is the value for x? What's a possible value for x? When y equals 5. Huh? So I'm just looking at the graph. You can plug it into the function too, is that what you're doing?
No, why is it 4 if x is 0?
It can be 2 of them. When I have x equals 0, it's right here. When I have x equals 4, it's right here. What y value is that?
Oh, and that's always 5.
Yeah, that's 5. So for when the y value is 5, there's 2 possible x values, right? Yeah. So that's kind of a signature trait of parabolas. When I have a certain y value, I can have 2 values of x. Okay. All right. What would I need to do in order to show that I want all of the possible values that are less than or equal to this function? What would I need to do?
Shade outside.
Shade the bottom.
Shade, so
Outside.
shade outside. Shade outside, or what else could you say? So here's outside. And below. And below. I'm just parabola. All right. So. Okay. So when I'm graphing quadratic inequalities, I want to shade something or something the something. Outside. Or inside the parabola. So like the one we graphed over here on the opposite page, we had to shade inside it. Right? This one we would shade outside, right?
Do you think that like after 12 years of writing your name on papers, people will remember?
I know. I threw them all away. Whoever was up there, because they waited too long. Okay. All right. So let's look a little bit more. Once you have verified your ideas with your teacher, you have. Good job. Complete the graph below to show all the solutions of, you could say y is less than or equal to x minus 2 squared plus 1, which is right here. Oh, we already did that. What should we do? We did it up here.
Actually shaded it.
Shaded it. Oops.
No, in the top it told you not to shade it.
I know, I didn't follow directions, did I? You guys are better than me. This new graph right here that we just did, I'm going to erase this because I'm stupid. Because I messed up. I wasn't supposed to shade it in.
You don't have to.
What? Ah! Sorry. Ah! Ah! Okay. All right. This new graph represents all the solutions to this inequality. What are 2 points that are in this shaded area? Come up with 2 of them.
Negative 14 and 12.
Huh? Negative 14 and 12? 0, 0. Looks like 0, 0's in it.
But it's, my answer is
Negative 14 and 12? I don't know.
negative 14 and negative 12.
Negative 2 and negative
Oh,
8.
negative. So he said, I know for a fact negative 14 and negative 12, negative 14 and negative 12 as a point is in this. How do we know that?
Because it's negative, negative.
Which two quadrants does this parabola live in? 1 and 2. I can pick any value from quadrant 3 and quadrant 4 and be like, yeah, pretty sure. So yeah, I would say Negative 14, negative 12, that would work. Right. I'm not exactly sure if I have negative 14, 12. I don't know if that one would work or not. I'd have to check, right? You think it would?
What is the little, like,
That? I don't know. It's exciting. Bam! I don't know. They're excited. Yay!
Did you steal this?
I did.
You should have a rule about no stealing in this classroom.
Or cheating.
Actually, yeah. Okay.
Actually, yeah.
Okay. Yeah, let's go to the other side. Ready?
Cheating.
Let's go to the other side. Whee! Okay. All right. So, for each inequality, graph below, shade each graph to indicate the solution set. Remember, the solution set is ordered pairs. All of the possible values which satisfy. So we want y. Move this over. Y is greater than or equal to x plus 3 squared minus 2. Are we going to go above, below, inside? We can extend it. Right? So give me a point that would satisfy that inequality. Negative 3, 4. 0, 0. Does 0, 0 work? No, 0, 0 is right here. Nice try though. Negative 5, 1, 2, 3, 4, 5, 1. 5, 1. Yeah, that works because it's on it, right? Okay. How about this next one? Where would I shade?
Inside it.
Wait, 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 wait. It's less than or equal to. So if this was less than or equal to, I'd be outside, but this is upside down. So we're going inside. Because, okay,
It's opening downward.
it's opening down, and so how can I illustrate this?
0, 0.
Because that's a good question what you're asking. Why is it inside and not outside? Because if I were to go outside, it would go all the way up here. And then I would have y values.
That would be greater as
bottom and top.
Right, bottom and top. So we're going below the parabola, right? Because we have less than or equal to right here.
So less than or equal to equal is down and
less than
And
or
it's
equal
so,
to.
right, it's less than what the parabola is. Exactly. So what would a point satisfy this one? 0, 0, that would work.
0, 0.
1, negative 12,
Actually 4.
4, yeah, that would work.
4 negative something that I don't care enough about.
You don't care. How about this one? Greater than or equal to,
Everything but what's inside the
I would go above it, right? Because I want greater than or equal to. So this time it's actually outside. Because my y values are getting bigger. Here my y values are getting smaller. Okay. Oh look, 0, 0 satisfies this one too. Woo! So these are all really nice because they're all solid, because they're all included, which is really nice.
the dashed one, would it be anything below it then?
Yeah, so it wouldn't be, so I could have anything on the parabola, which would be fine, but when it's dashed, you don't want any value on the parabola, just above it or below it, yeah. All right, so let's do this one. Now let's continue to expand upon your inequality knowledge. All right, look at this, these are already in vertex form, that's so nice. What's the vertex of this guy?
negative 3 and negative 4.
Negative 3, negative 4. So we go 1, 2, 3, 1, 2, 3, 4. Okay. Now let's find the roots. So I could do, so it's going to be 4, it's going to be plus or minus, so if I go like this, 0, it's plus 3, I'm going to add 4, so my roots are going to be -5 and -1, right?
Yeah.
-1 here, and 2, 3, 4, 5.
Actually, wouldn't be positive.
Would it?
Because 3 plus 2.
-3. Right. It was close though. Ah, I keep.
Wait, so you minus 3.
So I subtract 3, right? Because and so plus or minus means I have +2 minus 3, which is -1, -2 minus 3, which is -5. Okay, so I want all the values that are less than or equal to that. So where would I shade? Below. I'm gonna keep going on and on forever. Hooray! I don't know why, but shading is really fun.
Yeah.
Is it just me, or do you guys like it too?
I'm already on left.
I just think of the meme with the kid who's like, I love coloring. Have you guys seen that one?
On what?
There's a meme of a little kid who's like got a marker like this. He's like, I love coloring.
Has anybody here
Isn't
seen
that
the
a
Angry
little
German
baby?
kid?
Yeah. No.
Just beating up his keyboard.
No, I haven't seen that one.
Funny.
You only went -5. Don't answer me.
Oh, well. Are you okay? Did you figure it out? Okay. All right. Let me see if I can. Okay. So what's the vertex on this guy?
-6.
5, -6? Yeah? Okay.
Wait, what about the negative and
That tells me what?
all of that opens down?
Opens down, right. So we go 1, 2, 3, 4, 5.
Can you move your hair?
Oh, what? Sorry. Was it in the... Was it right here? Weird. Okay. This opens down, so I can't find any roots. Because if it opens down, it's not going to touch the x-axis, right?
So you would just have to plug in.
So, yeah, like, let's pick a point 1 away from 5. Let's plug in 4 and see what we get. 4 minus 5 is -1. -1 squared is 1, but it's negative. -1 minus 6 is -7. So we're at -6. There's my 2 points. And they're symmetric, so you really only have to find one. There's my parabola. So I picked 4, x equals 4, and I plugged 4 in, and I got -7. And then I know that since it's symmetric on the vertex, it's going to be on the same side, on the same place on the opposite side, right? Makes sense? Yeah. All the things that are bigger than or equal to, so I'm going to shade where? Outside. Boop, 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 boop. And above, yep. All of this stuff. Hooray! This is fun! Whee! I'm coloring outside the line, so.
Oh, you're such a rebel.
I know. I'm really bad at. I used to be really good at coloring, but I kind of like stopped caring after a while.
You start getting lazy and you're just like,
Yeah.
who cares?
They get the point. I'm not an artist. You guys getting it so far?
So you're not an artist? Yeah.
Go to the school.
Oh, yeah.
Okay. What's the vertex on this guy?
People just fight it now.
2, 3. I have something. Okay. 2, 3. 2, 3. 1, 2, 1, 2, 3. Does this one open up or down?
Down.
Down. And it's gonna cross the x-axis so I can find the roots. Or I can just plug in a value and figure it out.
They should have gave us one when we dash.
I don't know
Let me
if
dash.
it's open up or down.
So right here, this guy tells me it opens down,
Okay.
right? That was a good question though. So let's plug in 1. 1 minus 2 is negative 1, squared is minus, so that's gonna be 2. There's my parabola. I just plugged in 1. I picked 1. I could plug in 0 or whatever. It does, yeah, you can find the zeros if you want. So let's see. So
Plug something in.
I can plug something in, yeah. It's up to you. But I know that it's symmetric, so I can just pick 1 point and then plot it on the other side. Shade them at the bottom? Shade the bottom of it? Yep. Whee. And this goes on forever, right? Just like this. Hooray! Hooray!
Is Grayson still in this class?
Yeah, he must be ill. Is he sick today?
He's not FLA.
Oh, is that what that is?
What are they doing?
I'm They're doing business things.
They're trying to sell cookie dough in Tri-Cities.
Really?
No.
Remember last year you made a sell for your butt?
All right, what about this one?
You just told them I sold it off.
What's the vertex? Negative 1, 3. Negative 1, 3. Does this one open up or down? Up. It's positive. Opens up. So I'm going to plug in 0 because I know that it crosses at 0 here. 4. That's kind of what my parabola is going to look like. Where am I going to shade? Up or down? Inside or outside?
It's going to be inside.
Inside.
Wait.
Getting bigger.
Yeah, it's inside, yeah.
Inside. Woo!
We mean up, Lexi. Yeah, it's up.
Up. Yes, ma'am. The shading part? So, okay. That's a really good question. I wonder how I can explain that because
When it's greater, it has to be above the parabola. And it would shade the outside when it's greater, it would be below.
right. So, okay. If I shade outside, that's going to include everything that's less than these values, right? But if I shade inside, that includes everything that's more than. So I have to shade inside. You have to kind of look beyond the parabola itself. Yeah, so it's kind of like, yeah, it's not really inside outside. It's more like
You guys made that?
top bottom. I don't know. It's different. But,
The orange sheet?
okay. So what we're gonna do now, you're gonna tape this in your notebook. It's taped in already. Awesome. Okay. So you should have a free page below that, right?
Yeah.
Yep. Awesome. Let's do that.
So bad.
Okay. Okay.
You guys want? Who you
Okay,
guys want?
so how do we feel about graphing? Do we feel okay about graphing and shading and stuff? Yeah? Okay. Let's talk about solving now. So let's solve some. Let's solve x squared plus 2x minus 8 is greater than or equal to 0. Don't put a hole in your paper like I did. That's a 0. That's a 0. It's got a hole below it because I was too hard.
You're being really fast.
Going so hard.
That's why you're breaking all your pencils.
That's why I keep breaking the lead in my pencils. I also really like 0.5 lead, so that could be a reason why.
That's super cute.
I write small, so I have to use really small lead. Anyway, okay. So there are some steps we have to follow when we solve quadratic inequalities. So here's step number 1. We're going to solve as if an equation. And I know we have that pink thing below it, but okay, we're going to solve it as if it's an equation. So what we're going to do, really, we're going to replace the inequality sign with an equal sign. Again. What a waste. Lexi, I'm right with you, man. No.
I say we use electronics.
Electronics.
Say we don't.
Okay. This one is really easy to factor. You have to figure out what multiplies to -8 and adds to 2.
11 and 7.
Plus 4 and minus 2. So we have okay. Sometimes it's really easy to, you can see if you can factor it, but you can always use the quadratic formula. You can complete the square. You have all the tools necessary to solve these now. Google, Wolfram Alpha. Yeah. So I'm going to set each of these equal to 0. So I have x plus 4 equals 0. X minus 2 equals 0. So x equals what? X equals 2 and -4. Okay. What we're going to do now, step number 2, we're going to make a number line. No. I know, it's really frustrating me too. Trust me. I know. Make a number line. And we're going to put our 2 solutions that we came up with on that number line. So we're going to have 2 and -4. Okay. So what we did here, we created a sort of a 2-dimensional or 1-dimensional graph of our parabola. We found the roots. We can picture it like going this way. Whee, there's our parabola. But we really don't care about that stuff. Okay?
That's just gonna be that one line.
Right.
That's gonna be the y.
Exactly. Well, this is the x-axis, right? We could picture that.
Yeah.
Yeah.
Yes. But going up, it's gonna be the y. Like.
Yeah, we could like.
It's gonna be like if y were like 5, that's gonna be up there 5. But
Exactly.
It's gonna be x.
Right. So what we're gonna do? So we figured out that we have. So we have x plus 4 and x minus 2. Now we're going to put this back is greater than or equal to 0. So we're checking points really is what we're doing. We're creating intervals. We created an interval. So from, what is this arrow pointing to really?
No, negative infinity.
Negative infinity. So we have 3 intervals that we need to check to see. Because we can't just say, well, x is less than -2, or x is less than 2, and x is less than -4. That doesn't really make sense. So we need to check points. So we created 3 intervals. We have this interval, and this interval. So here's one interval. We have negative infinity to -4. Okay. Okay. Do you guys know what this means here? What brackets mean? It stops, but what can happen? It includes -4, yeah. So there's one interval. And then this little u means union, so it means also this other interval. So what's my next interval that I have?
Bracket
2.
2 to -4.
Well, we have -4 to 2, right? Yeah. And that's also included because of this or equal to. And then our next interval is 2 to infinity, right? Because really when we think about this, here's what our graph really looks like. Right, so here's really what our problem looks like. So we're checking like this area, and this area, right? That's really what we're checking.
Why?
To see where we're shading. Are we shading inside? Are we shading outside? We don't know where we're shading yet. We don't know yet. We gotta check. So don't draw that forever. That was just an illustration. Okay. So give me a number, not -4, because we know -4, if I plug in -4, I'm gonna get what? 0. I found that by setting it equal to 0, right? So we know 0 or -4 works. I know 2 works. So I need to check a number that's in this interval. So give me a number. What's less than -4? You want to try -6? Okay, let's check -6. So check -6. Okay. So if I plug in -6 to this guy here, I'm going to get, so really, actually, I'm going to plug it in here. It's easier to plug it into the factors. So I'm going to get -6 plus 4, -6 minus 2. And we don't know if that's greater than or equal to 0 or not. Yes. Well, this is the long way. Once you guys get used to it, you'll do the short way. Because you have to know where this comes from, what to do. Because this is kind of illustrating the short way. Because really what you're doing is you're checking signs. You're checking positive, negative. If I have a -6 plus 4, what sign am I going to get? -2. If I have a -6 minus 2, what sign is that going to be? Okay, I still don't know. What's a negative times a negative? Does that work? Yeah, that's greater than or equal to 0. So that works. I know that these numbers work. I tried them already. Okay. So I know that this interval works. Okay. So now we need to try and so I don't know if anything's going to work in here.
0.
Let's try 0. I don't think it's going to work, but let's try it anyway. 0 plus 4, 0 minus 2. Do we think we're going to...
It's going to end up with a positive and a negative, so it's going to be negative.
So is that greater than or equal to 0?
No. Okay. Why?
No. Nope. Okay. So, I think this interval here will work, but we have to check to make sure.
3.
So you want to check 3?
Yeah.
Okay. Check 3. Doesn't work. So we don't shade that in. It's not supposed to work, really, because it's like if we picture a parabola, you can't have shade inside and outside at the same time, right? So it's going to be 3 plus 4, 3 minus 2. These are question marks, by the way. Positive, positive, positive. Bigger than or equal to 0? Yes. Okay. Yeah. So, if I were to graph this on like a Cartesian plane, meaning a X and Y axis. Ah! Goodness gracious. I can't handle it today. I'm like Jean-Claude with these pencils today. Jean-Claude Van Damme. Oh, you guys are not that young. Come on. I'm not that old. Okay. Let's think about, what's my vertex of this guy? It's going to be negative b over 2a, negative 2. So negative 2. Negative 2 what? Negative 2, 4 minus 4, negative 8. It's going to be way down here. My zeros are negative 4, 2, 3, and 2. So pretend this is my parabola. I know it's not perfect, but...
It's not perfect.
So where we... Not at all, not even close. Yes, sir.
Wait, so how is x -2?
Wait, how do you graph that again?
Oh, I found the vertex. So the vertex I take... So this is way up here in standard form. Negative b over 2a
Negative 2
over 2.
times 1 is 1.
Oh, it is 1. Just kidding. Seriously, this is not the first mistake I've made today. If you can believe it. Yeah. Yeah. You're right. I'm sorry, Daniel. Sorry to confuse you. And then, was that your question too? Just to move it up? Or what is the vertex?
I don't know.
I don't know. Because I was wrong.
Rule number 2, tell the truth.
I was wrong. Okay. I need to take negative b over 2a.
Negative 2 over
Sorry.
negative 1.
So negative 1.
1 minus 2 minus
You hate it when teachers what?
negative 11.
When they write something, then they can erase it.
I'm so you have to be careful. I'm not always right.
Negative 11.
Negative 11. 1 minus 2.
Actually,
Negative 9. 1 minus 2 minus 8. Negative 9. So negative 1, negative 9. So way down here. I'm just pretending that's where it is. My roots are...
It's the same thing.
Yeah, my roots are at 2, negative 4.
That's what we just had.
I know, it looks a little different. Okay, where am I shading? Inside or outside?
That looks so more like mine.
Greater than 0 should be inside.
So, okay, so let's think about this.
Oh, you're doing
Here's my number line.
that one. Yeah, it's
Outside, but above what?
0.
0. Because I want everything that's above 0, right?
And what are those other ones though? 3, negative 6.
What do you mean?
0.
So 3 works, 3's over here, negative 6 works, 0 does not work.
Why do you want everything that's above 0?
Because here's my inequality right here. Everything that's this parabola is above 0.
So exactly like your rising 0 then?
Your what? Yes. So this is what my graph is going to look like.
It was 914.
Yeah? You get it?
Not sure.
Was it 914?
Negative 1, negative 9. Yeah.
So wait, it's below the
So
parabola,
let's
but
say
above
that
0.
the 0 was like a 6. Would it be everything above 6 then?
Yes.
David?
Yeah. So now we're getting into, we have another defining thing, right? We want it above 0. We want all the y values that are above 0. And we checked everything in here and it didn't work, did it? Because our parabola is right here. So we want outside the parabola, but bigger than 0. Does that make sense at least a little bit?
If it were greater than, or I mean, yeah, greater than 0, instead you shave the bottom of it.
If it was less than or equal to 0, you would shade the bottom. Yeah. All right. You guys doing okay so far? Do you want me to do another example with you?
No.
From the homework?
Yes.
Okay, that's what I thought. Okay. All right, you guys got this, okay?
So one less problem.
One less problem for you to do.
I got one less problem than
Miss Ham, you know what's good about recording?
What?
Now the people that come today,
Mhm.
you can show them the recording to catch up.
Yeah.
You can show them the recording.
So I
Oh,
think
yeah.
we're missing the video, no?
All right, I'm gonna stop the, or should I keep going? I'll just keep going.
That's a
That's
lot
fine.
of
Hello, home slides.
Okay. All right. So this is my. Let's do this. Okay.
An hour and 30.
So your homework is
1, 2, 3, 4, 5, 6.
on the calendar.
More than 3.
And
Go ahead, write it.
no, you said those ones.
I'll write it down.
what's
Not too many. It's like 12 problems.
Okay.
We didn't have it.
That's
And
what-
I didn't do the native Americans. Except for the end of the last one.
but I was still.
Okay. So I'm gonna do number 12.
This is not for us.
We didn't have anything on art.
I'm gonna do. I think you guys can do 12, 14, and 16. Because those are just graphing with y is less than, and just shading in the appropriate area. So I'm going to do number 18, okay?
So if you don't have to do it.
Okay,
Yeah.
I have a question about
Yes.
text you get no credit. You don't get any credit anyway.
Well, here's what I mean. If you like only follow along in class and don't actually try it, and you turn in the practice problems that we went over in class, you get 0 out of 5.
So just the 5, like if you just wrote.
Yeah, if you just do those 5, then you're not going to get any. You're going to get a big fat 0. I know it doesn't affect your grade, but if you want to redo your test, it tells me you didn't actually do it.
Yes, ma'am.
Have you been doing that? Okay. It's mostly a problem in my geometry class. You guys haven't been very bad. So 18 says x squared minus x plus 5 is less than 11. Okay. Okay, so here's what I want to do with this. I want to get 0 on one side. So I'm going to subtract 11. Because I want 0 on that side. So I'm going to have x squared minus x minus 6 less than 0. Okay?
Miss Hannah,
Yeah.
your calculator.
Is that one not working?
It's just 13 that doesn't work apparently.
Really?
It's
Great.
the only one I go for every time.
Awesome.
13's an hour.
Well, that's my number.
6 is...
I don't think it's
No, it's been plugged in.
That
for
always takes my
years.
number.
6 is the one that's been giving me problems.
Supposed to be number 11.
Okay, I'm going to make this into... I'm just going to I'm going to factor this. What multiplies to negative 6 and adds to negative 1?
3 and 2.
3 and... What about 3?
Negative. Well, some of them are positive.
Negative 3 and 2.
I'm not going to tell you the secret.
Okay? You don't have to make it into an equation. That's fine. I don't care. That was just the way that Patrick JMT said it.
I hate you.
Oh,
I'm just kidding.
Wow.
you just broke rule number 1, Zeusy.
Are you?
Yeah, be nice.
Rule number 1.
I'm moving right now.
I'm using those out too.
She was being that. She was telling the truth, but...
Garrett.
Hey, that was a lie. You know I don't hate you.
Oh,
I don't hate
Oh,
you.
that
So technically, she either breaks rule number 1 or she breaks rule number 2.
I'm just a rebel.
I know you are. Okay, let's draw a number line.
You're not nice. You see, you break your rule now.
We have, so x equals 3, negative 2. We have negative 2 and 3, right? Okay, let's check. First of all, let's check 0. 0 is going to be negative, positive. That actually works. I checked 0.
Wait, why does it work?
So let's check 0.
That should be your first rule.
Yeah, but Miss
What?
Really too much.
Okay, well, that should be your first rule because most people don't even read through them.
So if I plug in 0, I'm going to get 0 minus 3, 0 plus 2. I don't know if that's less than 0, but I get a negative times a positive. This is a negative, less than 0. It works.
When I flip, trying to get on my page,
Right?
and I flip to like 400.
Right? Okay, so that's that guy. So I know I'm going to shade somewhere. So what kind of problem am I going to have? Solid or dashed, first of all? Wait. Dashed. So here's -2. Here's 3. My vertex is going to be -1/2. Wait. 1/2. 1/2 something or other. This is when a calculator comes in handy. I know it's gonna be 1/2. No, don't be. Okay, let's check this. Has to load first. This is like watching grass grow,
I think it's like watching a calculator.
except way slower. Yeah.
Does the number line count as graphing?
No, it does not count as graphing. No, it helps though. I think it helps to visualize where you're gonna shade.
It's going to be -6.25.
You sure?
Should be.
So my vertex is gonna be at 1/2. Oh, what is this? Do you guys see this? Look at that. What the heck? What is this?
Somebody mentioned that. Well,
So when I find my vertex, I do -b/2a. So -1 is 1/2, right? Okay, so I'm gonna just plug this in. I'm gonna go 0.5 squared -6.25. Good job. So it's down here somewhere. So it's going this way. Just do a rough sketch, you guys. You don't have to make it perfect because obviously I'm not. I'm gonna. It's a dashed one though, right? This is 6.25. This is my vertex. Okay. Where am I gonna shade? Above or below?
inside.
Lexi, it's October.
Not Christmas yet. 58 days.
It's always Christmas.
Every day is Christmas.
Christmas is
Oh wait, hang on, hang on.
the way of life.
Hang on a second. Hang on.
There's 3 electives next year.
Oh,
Or
beat you to it.
I'm going to make sure to take like health classes so I can get done with my DP credit. And by the time I'm a senior, I can take classes in the morning because you have to take 4 years of election. So I can take a class in the morning and go.
Jeez, that's not job for us level.
Okay, so we want above or below 0?
Below.
Below. Okay, that's how you would graph it.
Wait, what about that?
So I want this guy right here,
You want less than 0?
less than 0.
It's always going to be greater than or less than 0.
It's easier to get it to 0. Okay. All right. you want me to do one more? What, yeah?
That's a lot.
Let's do number, what, 20?
That's basically our x.
Yeah, basically, yeah.
Alright, I'm going to do one more for you guys. So 20 x squared minus 5x plus 12. Is greater than 6. Okay. So what am I going to do first?
-6.
Minus 6.
I don't think anyone is listening.
Yeah, nobody's paying attention to me.
I'm paying attention to you.
It's x minus 3 and x minus 2.
Good job. So x equals 3 and 2. So, okay. This is pretty simple. Yeah. Okay, here's 2 and 3. I'm going to check 0 first, just because 0 is easy.
Why do you have to draw a number line?
You don't have to. I like to. It's just easier to visualize that way. Okay, so I'm going to get a negative times a negative. Is that, so negative times a negative, is that bigger than 0? Yes. Positive, right? Negative times a negative. It's a positive. That's bigger than 0. So that works. So I'm assuming that the other part works too, right? Let's just check just in case. Check 4. I'm just going to check 4. Well, you can probably do it like 4 minus 2, 4 minus 3. That's plus. Huh? Oh, sorry. So 4 minus 3 is 1. 4 minus 2 is 2. Positive 1 times positive 2 is a positive. I just chose it. This is where you have some freedom. You're like, I'm going to just pick this number. Because I didn't want to pick 1.5. Because that's it. Yeah. You check the intervals. So say I picked 1.5. 1.5 minus 3 times 1.5 minus 2.
You mean 2.5.
Or sorry, 2.5, yeah. 2.5 minus 3 is a negative. 2.5 minus 2 is a positive. A negative times a positive, that's a negative. That's not bigger than 0, so that's not going to work. Right? Yes, ma'am? Do you have to go? Okay. All right. 1 second. Yes, sir. What do you mean? If I picked 2.5?
No.
What are you trying to say? So you have to plug it in here.
So, no, but
So, negative 3 times negative 2. That makes it positive, which isn't that.
I plugged in 0.
So you just get your ready right now.
0 minus 3. So 0 works.
Yeah.
And 0 is back here. Right? Yeah, these are positive numbers. Yeah, 0 is back here. It's not always in between. Is that what you're confused with?
See how nerdy it
All right, and then I'm going to graph this just really roughly.
You need like white.
2 and 3. It opens up. It's going to look something like this. And I'm going to shade above 0. Above 0. All right? You guys see it? Oh, this is a dashed one too. Dashed. All right?